Let's learn about polygons. What do you call a parrot that flew away? A polygon. So on our agenda, we're going to start with some polygon vocabulary. We'll go through a lot of formulas having to do with the polygon angles, interior and exterior, and the area formula. It involves perimeter and then something called an apothem. So let's get ready. You're going to need your notebook, pencil, and calculator. Definitely have to take notes along the way, draw the pictures, lots of formulas and new vocabulary to write down. Feel free to stop it and do the problems and write out the charts. There's a lot in this video today. We're going to start with the names of our polygons. So polygon is a many-sided closed figure with straight sides. So if it's a three-sided figure, it's a triangle. A four-sided figure, which we've been working on recently, that might look like a parallelogram. We want to back up and even be more general and go for four, which is quad. So we're going to call that a quadrilateral. 5 is a pentagon. 6 is a hexagon. I'm going to skip 7 and go to 8, which is an octagon. Skipping 9 and going to 10, which is a decagon. And 12 is a dodecagon. So 7 is a hepta or septagon, 9 is a nonagon. We don't usually talk about those. The word regular, you're going to see that with our polygons, and it's not a regular word, it's really an important word. And if you see something like a regular hexagon or regular octagon, that little word is very loaded. It tells you that all of the sides are congruent, so you're allowed to put all those marks on, and all of the angles are congruent. And that's going to be a regular hexagon. Let's talk about the angle. So we've done it for triangles. We know that all the angles in a triangle add to 180. We know that all the angles in a four-sided figure add to 360. So here we have a five-sided figure, a six-sided figure, and an eight-sided figure. And I'm going to draw the diagonals just from one vertex and see how many triangles there are. 1, 2, 3. I'm going to do the same for my hexagon, draw my diagonals. 1, 2, 3, 4. Draw my diagonals. 1, 2, 3, 4, 5, 6. So what do you notice about the number of sides compared to the number of triangles? Five-sided figure has 3 triangles, six-sided figure has 4, eight-sided figure has 8. Hopefully you notice that they have 2 less triangles. So that will help us figure out the sum of all of the insides, because if the triangle, all the sides add to 180, and something has three triangles in it, then I can do 3 times 180. So if I'm talking about a pentagon with 5 sides, I would do 5 minus 2. That fits in 3 triangles, and we have 3 times 180 for 540. So all the sides of a pentagon, not all the sides, all the angles of a pentagon add up to 540. And you can do the same for 6 minus 2 times 180 for the hexagon, etc. So here's our hexagon. So we do need to figure out what they all add up to in our hexagon. So if I plug in n is my number of sides, so 6 minus 2, that means I have 4 triangles in there. And when I multiply that out, that's going to equal 720. So unlike when we were doing triangles and everything just added to 180, we're going to have a bunch of different shapes. So you're always going to have to figure out what that specific shape adds up to. So I know that this is going to add up to 720. So I'm going to go around and collect my variables, collect my integers. I do see the red congruent mark, so that means that this one is also 10x plus 20. So when I collect all of my x's, I have 75 x's. When I add or subtract all of my numbers, it adds to 120, and I know the total is going to add to 720. So I'm going to solve that algebra equation. I'm going to subtract the 120 from both sides, and then I'm going to divide by 75, and x equals 8. Let's look at one interior angle, and this is only for regular polygons. So regular, again, means all the sides are the same, all the angles are the same. And what we just said for our hexagon is that all the hexagon angles are going to add up to 720. Well, if they all add up to 720 and I have 6 of the same angles, then I can divide by 6, and one angle is going to equal 120. They're all going to equal 120, only in a regular polygon. So we have a little formula. We take the formula that we just did, the number of triangles minus 2, number of sides minus 2, times 180 divided by the number of sides. So what is the measure of one angle of a 12-sided figure, the dodecagon? So 12 is going to get plugged into both of those, and I end up doing 10 times 180 divided by 12. So that would be 1800 divided by 12, and that comes out to be 150 degrees. So one angle in a regular 12-sided figure is going to be 150 degrees. So let's use what we just did with interior to get to the exterior. We saw those with exterior angles of a triangle where I extend one side. If these are all regular polygons, so if this is a regular triangle, then my angles are going to be 60, my interior angles. So if I'm trying to get to my exterior angle, it's a linear pair, it's supplementary, so it's going to be 120. Inside the square, we know that all of this adds up to 360. Divide it by 4, so we're looking at 90, and my exterior angle will also be 90. Here we have a 5-sided, so 5 minus 2 times 180 is 3 times 180 is 540. Divide by 5 is 108 for an interior angle. So if I'm working my way to the outside, the exterior angle of a regular pentagon will be 72. And then we just saw with the hexagon that inside is 120, so my exterior angle is going to be 60. So the interior and exterior angles are supplementary. Hopefully there'll be an easier way to figure this out, right? Because I don't want to have to go through the interior every time. So if I go back and figure out how many exterior angles each of them have, a triangle has 3 exterior angles. So those are going to add to add or multiply to 360. The square has 4, so when I multiply that, I get 360. The pentagon has 5. When I multiply that, I get 360. And the hexagon has 6. When I multiply that, I get 360. So conveniently, all the angles of any polygon are going to always add to 360. The sum of the exterior, all of what they add up to is going to be 360. So if I'm trying to figure out one exterior angle of a regular, only for regular polygon, then it's going to be 360 divided by n. And then you don't have to go into the interior to work your way out. You would just divide. So 360, if we're talking about our hexagon, we divide by 6. So I know the exterior angle would be 60. So to recap our angle formulas, the total sum of interiors is the number of sides minus 2 times 180. And then if you want one interior angle of a regular, you're going to divide by n. All the exterior angles of a polygon add to 360. And if you want one of a regular, you're going to divide by n. Let's look at this formula for the area of a polygon. It's quite different. We have A equals 1/2 A over P. Notice I have a capital A and a little a, lowercase a, and a capital P. The A's are different. When you have a capital letter, it means you've done some math to calculate it. When you have a lowercase a, in this case, it means a measurement. Capital P means something's been done to it. And then we've got the 1/2 there. So the capital A is the area of the whole thing. The lowercase a is my apothem, which we'll learn about, but that's a new vocab word for us. And then P is perimeter, and we know that perimeter is the distance all the way around. So what the apothem is if I go to the middle and I drop the height right down, and it's essentially the height of this triangle, which is different than this out here because I can see that that is the hypotenuse, so I know it's longer than this. So this is the apothem, we can call it A. It's also the height of the triangle. So we need to figure out that, and we need to figure out the perimeter, and then we can put that together for the area. So let's start with a regular hexagon, so they're all the same. And each side is 8. And we want to find the perimeter. So the perimeter here is just going to be 8 times 6, which is 48. So we did a little bit to that. That's why it's a capital P. We're going to use that in our formula. So now we want to find the area. So I know that my perimeter is 8. So I'm going to drop this height of this, which is A, which is my apothem. And because this is a regular hexagon, I know all my angles are 60. So if I'm on my triangle here, this is 60. And if I drop that height, which is my apothem, I know that this is 30. I know that the sides are 8, so the hypotenuses in here are also 8 because these are little equilateral triangles. So the bottom is 8, but half of the bottom is 4. So what I want to look at is that little right triangle there with a side of an angle of 60, 30, 8, and 4. It is a right triangle. It is a special right triangle. It has the 30, 60, 90 relationship. Remember, across from the 30 is the smallest side. Double it, you have your hypotenuse. And then when you go to your side across from your 60, this is going to be 4 root 3. Which is great. This only works for hexagons to be able to apply the 30, 60, 90. So we do need another way of calculating that. So I'm going to show it to you while we're on this problem. So if I know that this is 60 and I'm looking for A and I know my bottom is 4. Normally I won't know this because it won't be an equilateral triangle. So now we have a right angle and I know one side and one angle. So we can use right triangle trig. We need to look at what we have. We're looking for opposite and adjacent, and that's going to be my tangent. So we're going to do the tangent of 60 equals A over 4, multiply both sides by 4, and then on your calculator you would do 4 times the tangent of 60, and we get 6.93. 6.93. That is my apothem. So I'm going to put that together with my perimeter and do my area formula. Area equals 1/2 my apothem, which is 6.93, times my perimeter, we said was 8 times 6, which is 48. And then we get an area of 166.32, and that would be units squared. For polygons, you need to know the names of the polygons, their interior and exterior angles, be able to find the perimeter, find the apothem, find the area. So let's try it again. This is with a pentagon. These are the steps. Find the perimeter first, find one interior angle, find the height, and then put that together for the area. So let's find the perimeter. I have a side of 6, so the perimeter is going to be 5 times 6, which is 30. Now I need to find one interior angle. So that's going to be n minus 2 times 180 divided by n. So my n now is 5. 5. So we're going to have 3 times 180 divided by 5, which is 540 divided by 5, which is 108. So the whole angle is 108 there. And then we're going to cut that in half because when you draw this, they do bisect that 108. So we're looking at 54 there. So I found one interior angle. Now we want to find the height, which is my apothem. I'm told that the side is 6, so this is a perpendicular bisector, so each of these are going to be 3. So I've got my little right triangle with an angle of 54, an opposite of A, and an adjacent of 3. So I'm doing the tangent of 54 equals A over 3. Multiply both sides by 3. And I get that to be 4.1. My apothem is 4.1. And we're ready together. So we've got all of our numbers, our perimeter and our apothem. So area equals 1/2 my apothem, which is 4.1, times my perimeter, which is 30. And I get an area to be 61.5, and that would be units squared. Nice work.